y minus z equals 0.
Okay.
So we're going to use that.
Okay, so let us try this. I think we should be able to figure out the volume formula for a cone.
The general formula?
Yeah, the general formula. It really shouldn't be that hard.
No.
But we should be able to do this, right? If we can't do this, Calc 3 was not an exercise worth doing. So, here's a cylinder, right? And if I put a cone in this cylinder, I want to go like this, right? Cone, cylinder. You all are familiar with this? It's a dunce cap, right? Okay. So, what are the two things that are important about the cone?
The circle and the height, I guess?
Yeah, the height seems like an important thing, right? Okay, so we'll call that H because we're creative. Yeah, and some damn thing about the circle better be important. You could do that in a number of ways, right?
Angle. I'm assuming you would probably want an angle.
Oh, so careful. If you make a radius and an angle, those are related.
Yeah.
Right?
You could have one or the other.
Yeah, so we could either have like an angle up here at the top, or we can have a radius down here at the bottom. I'm going to put a radius down here at the bottom. I call that R, just to make my life easier. But yeah, we could do this with an angle too.
Does the dot need to be in the center of the corner?
It's a radius, so
As
probably.
long as it's circular all the way down,
It tilts the cone.
probably
Are you talking
not.
about a right circular cone or,
Or
a
if you place
skewed
the point of the
circular
cone
Yeah.
skewed to.
So I'm going to do it this way for right now.
Yep.
But I think you could probably convince yourself that it doesn't matter. So let's try it this way, and then we'll see if we can convince ourselves it doesn't matter.
Okay.
I'm not sure. I don't actually remember the formula for the volume of a not right cone. But we can figure it out. So I have this thing, right? Yes? Okay. What should I do?
Okay, so we know it's
Look it
triple
up in the
equal,
book.
but-
No. You use this when you forgot the formula on the test, okay? That's what I always used it for.
So we know
Good math students forget all the
we're probably
formulas.
going to be using cylindrical for our.
Yeah.
Cylindrical seems legit, right?
Yeah.
Okay, so if I'm doing cylindrical, I think that means I need a triple integral. And what should I be triple integrating?
R theta and z.
Okay, so there should be a dr, a d theta, and a dz up to ordering. Those are wrong for right now, just FYI. What else did we forget? We need to be integrating 1, right? And we need a, Leslie, what did I forget? Good. The conversion factor, right? Okay, so in this case, it's R, right? Okay. Now, what have I screwed up fundamentally?
We have two variables named r.
Yeah, I have two things named R, and they mean different stuff.
Make one a capital.
Yeah.
Okay.
We're going to make this. We're going to make the variable.
Yeah.
Cool? Do not rename the variable in polar. It will screw your shit up. Okay? So, where do, I need some like axes for this friggin' picture, right?
Maybe.
That's a good one.
Yeah. Assume that's.
That one seems legit, right?
Yeah.
Where else?
I guess we're using.
Yeah, you gotta go like this way or that way or
Yeah.
something. And yeah, to get right hand rule, I kind of fixed that way. You guys all good with this? Okay, so I got my coordinate axis. Now what? Where do the z's range?
Okay,
From the
so like there
base
has
to
to
the
be
point.
0 to
Yeah,
negative h minus
0 to h.
So some of you are saying 0 to h.
Oh, no, it's not. No, it's not.
And others of you are saying from 0 to some kind of
function based on.
Oh, yeah.
thing based on some kind of other stuff, right?
If it is the last variable, it is.
You guys see that? So why isn't it 0 to h?
Other side is.
Yeah, because you want it to be in the cone, right? You want to find the volume of the cone, not the volume of the cylinder. If you do 0 to h, you will get the volume of the cylinder. You guys all see that?
Wouldn't it be 0 to h if it's the last variable used?
That's good.
If you fix it.
It's not going to be the last variable used. It can't be, right? You guys all see that? Because it's the first one I need to get rid of, so I need to switch that order around a little bit. I'm not sure this is the right order either, but I know z has to go first. So they go from 0 to, uh-oh,
Uh-oh.
0 to something. 0 to the cone, right?
Yeah.
You do like the triangles
The function of the cone again.
make a triangle on that and then find the.
That is such a good idea. Okay, so here's your cone, right? Well,
Well, we can assume that theta is 0 to 2 pi, so it doesn't really matter on the other side.
I think it matters.
Oh, okay.
You guys see what I'm running into? There's like two sides of this cone. There's an absolute value happening in there, and I don't really want to pick a plus or minus, right? So what are you going to do to cut that out of there?
Just double it.
Yeah, take the right-hand side and double it or something, right?
That would be a capital R for this one, right?
This distance is capital R. This is the R axis. Guys with me on that?
Except you labeled it as the x-axis on the other picture.
I meant to do that. This is the x-axis. This is a triangle sliced along some R line, right? You guys see that?
Yeah, I see it.
I'm trying to emulate Merrill, so I'm labeling all my stuff. You wouldn't. Okay, so what else do I know about this picture?
You know what the area of that triangle would be.
We know that the top R is h.
Yeah.
Yeah, I know that this distance here is h, right? And then I also know that I'm having a hell of a time sorting out about plus, minus, ds. It's also a cone, right? So it's symmetrical. So I'm going to pitch the other three quadrants. Is all good with that? So I'm going to just do 4 times first quadrant. So I'm going to pitch the left half of this picture.
Couldn't you just find a,
Yeah, you could sort this out otherwise too.
like a z
It would
equals a
work.
negative square root thing?
You could figure this out the other way too. So, what? Equation of a line, maybe? Right? Because the z's go from 0 up to that line. Like, this is the height you're talking about, right? So, what's the equation of that line?
Isn't the area of a triangle just 1/2 base times height?
I don't need the area of the triangle. I need the height of
This.
this thing at,
H
at
over-
any specified z value.
H over capital R times, are you doing X?
Just think mx plus b.
Yes.
That's what I was doing.
So
Think
what-
mx
what's-
plus b. So this is z equals
What's your b? That's h.
h plus
Plus
H over R times
Negative
whatever your
H.
variable is.
Negative
over r, big R.
right? Drop h in run capital R times your other variable. Okay. Y equals b plus mx. Kind of.
Although
Except
would-
with totally different
although,
letters.
Wouldn't
Yeah.
it, would it matter considering? Yes, it would. No.
Okay, so my z's go from 0 up to this thing. So that's h minus h over r times little r. Am I okay putting a little r in those bounds?
Yeah, as long as you use the.
Yeah, as long as the r integration happens after this one. Yup. Cool. Good to go. All right, where do your z's live? Wait, no, we just did z's. Where do the thetas live?
You said only first quadrant, correct?
Yeah, I exploited symmetry, first quadrant. That's going to change my thetas, right?
Yeah, it's 0 to pi over 2.
So my thetas are going to live from 0 to pi over 2. You did not have to do this. You could actually get away without this at all because the r value, right? That's why I drew an r-axis instead of an x-axis. The r values are all positive, right? So you get this kind of picture spun around anyway. You don't need that other side. But if you're having trouble, exploit symmetry and cut it out. And then where do my r's live? From 0 to capital R, right?
Capital R is your input, basically. Like-
Yeah. So I'm going to have two inputs, right, for this volume. There's going to be a height and a capital radius. What's up?
If we made it, if we took that 4 off the outside and made it 0 to 2 pi, would that work out the same?
Yep.
Yeah, okay.
Yeah, and that's really because I drew an r-axis here and not an x-axis. If you drew an x-axis here, then you're screwed. Okay. So, can I split this up into the usual way I do this? Like, can I bust this into 3 pieces and multiply the answers?
No, you can pull the d theta out because it's not correlated, but the other two, one is dependent of r.
You guys see that? So you can't always do that trick, right? So don't always do that trick. But you can sometimes. In here, I can get a theta bit out. So I've got 4 times the integral from 0 to pi over 2 of 1 d theta. But then in this other bit, I've got my 0 to capital R, and this guy depends on little r. So I've got 0 to h minus hr over capital R of r d d what? Good. Make sure you keep the order right. You guys all good with this? Okay. What do you get out of this guy?
2 pi?
Yeah, 2 pi.
2 pi?
2 pi or not 2 pi?
Cool. That's good, right? That actually means that it didn't matter, right? Whether I exploited symmetry or not. Okay. Then out of this stuff, let's see, I got the integral from 0 to capital R. What do you get when you integrate little r with respect to z?
HR minus HR squared over big R. You understand where I'm getting that?
Yeah. So you get r times z, right?
Yeah.
And you should be evaluating from 0 to h minus hr over capital R. And those bounds are getting crammed in for which variable? Z, right? And then we need to be integrating dr at the end. So we get 2 pi times the integral from 0 to capital R of hr minus hr squared over capital R dr. Everybody with me?
Yep.
Okay. So I got 2 pi times
So h
Oh.
squared over 2
h r squared over 2
minus
minus
hr cubed
Cubed over
3r.
3 big R, evaluated from 0 to R, big R.
So it's just the r.
Everybody with me? And I'm going to evaluate, oh, what did I screw up here? I wrote something dorky.
Big parentheses around everything.
Well, yeah, for the 2 pi.
Right, 2 pi needs to be multiplied by all of that stuff. So now I got a 2 pi times, what do you got next?
H or
Big R.
H big R squared
Big R squared
over 2
over 2 minus
H
Big R squared
cubed
over
big
3
R cubed.
over, oh, the R's can't cancel out? And the big R's not?
No, the big R should cancel out. Why? What? So why am I like looking at this and standing here like, can I just F this up on the board in front of everyone? So like, yeah, there's a lot of R's, right? When you plug in a capital R, here you're going to get an R squared, right? And here you're going to get a capital R cubed. There shouldn't be a capital R cubed in the formula for the volume of a cone. You guys see that? Because capital R cubed,
Be volume times height if you did that.
yeah, it would be a volume unit times a height. That would be bad,
Mhm.
right? But thankfully one of them drops off, right? So I got 2 pi times, and in here you got, let's see, let's slash an R. So I got h capital R squared over 2 minus h capital R squared over 3.
Which, if you use if you set both the denominators to 6 and multiply the left one by 3, multiply the right one by 2, you could end up getting h over.
Right? Find a common bottom.
H.
And so you get out of this in the end
When you cross cancel the 2, then
that the volume is
Yeah, once you cross cancel the 2's, you end up getting pi
Two
hr
cross-
squared over 3.
the 2 pi.
cross cancel is not even a word, guys.
Okay, well we
Distribute.
Okay, so you get a 2 pi times
sorry.
h
Yeah, it's just an hr squared.
r squared over 6, right?
Yep.
And then you reduce.
Reduce. The word is reduce. Sorry.
Can't believe you're actually apologizing, but
Okay.
so you get pi times h times r squared all over 3.
Yep.
Yes?
Is
Does that look familiar?
Oh,
Nope.
Yep,
Nope.
yeah, that's exactly
How
what
about
we got there.
1/3 pi r squared h?
Yeah.
It's 1/3 the volume of the cylinder.
Okay.
You guys see that's the area of the base?
So should the big R have gone away then? Or is that just?
No, the big R is the radius of your cone, right? And the radius of the cone should matter.
So we should have made that little R then, the other one big R, right? Like,
No.
It doesn't matter.
The big R just
Yeah.
becomes a little R when
If you want to get a little r in the
yeah,
formula,
'cause that looks fun for you.
so here, I'll fix it for you. We'll do this. Let capital R equal little r. Is that better? Fixed now? Yeah, you're right. We probably should have done it the other way because I know what the formula is supposed to have a little r in it, right?
But the problem is then you're saying dr from 0 to r.
So, if I had done that, I would have this in here, right?
You see,
Which we could have done. I thought about doing blue R's and black R's, but I really didn't want to deal with the fact that the video doesn't pick up blue and black well enough for you to tell them apart.
Yep, and then they're like, why don't
Well,
we reduce that?
But
They're
yeah,
different Rs.
in that case, the blue R and the black R would not cancel, right? And in the end here, you would end up with a blue R, which is not a black R. Those are different somehow.
Now it's
Now it's better. Okay, cool. Question, Steele? What would my rationale be for thinking that this is probably the formula regardless of whether this dot is directly above the middle or not?
Well, I could see a rationale for like doubting that, because if you can imagine taking the top of that cone and yanking it all the way down to the x-axis,
Yeah,
and
so-
it would go to 0.
Keep in mind that if you yank it down, the height of this thing is changing, right?
Yeah.
So you're not, what I'm saying is that you would be allowed to move this around in that circle up there.
Without changing the height.
Yeah, without changing the height. So you'd have to keep it level at least. So what would a good rationale be for saying that that might still be the same volume?
Like the angles are changing equally. So like,
There's
as
symmetry.
you're making one side bigger, you're also making the other side equal to that.
Yeah, I think a good rationale would be to cut it into these little disky guys.
Yeah.
You guys see that?
Oh,
And those discs go from being twice R wide to being 0 wide, regardless, right, of where that point is. And they vary at the same kind of rate, right? You're robbing from one side to get the other. You guys see that? But the little height pieces are still the same size. And so when you add up the height pieces, you should get the same formula.
How would you make it not flat? You said that.
How did I make it
I
not?
know you said like unless it has to be. Flat.
Oh, yeah, when you're moving this around, what I mean is you have to keep the height the same. So what I'm not allowing you to do is take your cone with your base on my hand and go like this,
Okay.
right? Because if you do that, then the volume does go to 0 immediately, right?
What are those kind of cones called when they're like?
I don't know. Skew cones? I would call them skew cones. We could test this experimentally. How can you do this experimentally?
Just move it and try it.
oh
Put
gosh.
some containers, some water.
Get a container and an ice cream cone that's the same height, and then fill the ice cream cone with water 3 times. And by the 3rd time it will have dissolved, and then you won't have to do this again. No, I mean, you could make a cone, right, and a height. Actually, Annie was asking for one of these the other day.
Yeah.
So if one of you would like to do that with skew cones for your project, that would be an idea.
Could you do something similar if you wanted to change the height of the point on the top? If you were to add an angle?
Yeah, you could fiddle around with some other stuff and come up with other versions of this. But it's nice to know that the height is just the difference between the z coordinate here and the base.
But you could still use the triple integral the same way that we did if
Yep.
you were to define angle between z and r.
Yeah,
Okay.
it'll get more annoying, but you could do it the same way. It'll get really annoying if you let this thing leave that circle.
That's what I'm saying.
Yeah, you can still do it, it's just more annoying.
Like, give me a radius, a height, and an angle
Yeah.
deviation from the right cone.
Yeah, then you could do this still.
That sounds good.
Yeah.